In last lecture, we have designed DFA for condition W contains substring. Here we are going to handle condition W ends with. So let's say W ends with AB. Now even in substring condition and also for ends with condition, we have to look for AB. That is the common part. But the difference is, in substring condition, we have to find AB only once. For ends with condition, it does not matter how many times AB appears in the string should end with AB. In case of substring, once we find AB, then we are sure that this string contains substring AB and the string should be accepted. But in case of ends with condition, the string should end with AB. Now someone may think that start processing the string, go to the end, then come back and check if last two symbols are AB. But DFA does not have that capability. DFA cannot go back and forth on the string. DFA has to process each symbol, and when all the symbols are processed, when the complete string is processed, if the DFA is in final state, the string is accepted. If the DFA is in non-final state, the string is rejected. So for ends with condition, here we find AB, but but string has not ended over here. Here also we find AB. Here also we find AB. So we are going to design the DFA such that while processing the string, if the last two symbols are AB, while processing the string, if last two symbols are AB, DFA should be in final state, otherwise it should be in non-final state. So here again we find AB, DFA should be in final state, but string does not end here. We have to continue to process the string. So again we find AB, DFA should be in final state. Here string ends, so the string should be accepted. For all other instances while processing the string, the DFA should be in non-final state. Here it should be in final state. So this is what we have to consider when we design the DFA. Now we are going to design DFA for W ends with A, W ends with AB, and W ends with ABAA. So for ends with part, here the length is 1, here length is 2. So for these two cases, designing the DFA is relatively simple. Here for the ends with part, length is 4. So for this case, we have to develop proper logic and proper procedure. So let's start with W ends with A. Now if you consider string epsilon, this does not end with A, it should not be part of the language. If you consider only string A, it ends with A, it should be part of the language. It is part of the language. Then any string that ends with A is part of the language. Any string which does not end with A is not part of the language. So let's start with initial state P. Now as long as only B's are coming, string cannot end with A. So as long as B's are coming, we remain in state P. If A comes, last one symbol is A. Here we have to handle condition W ends with A. So whenever last one symbol is A, the DFA should be in final state. If the last one symbol is not A, the DFA should be in non-final state. So here we find A, last one symbol will be A, we will go to a final state. So if we consider string B, the processing starts in P. Here it remains in P, here it remains in P, here also it remains in P. Now if you find A, we go to state Q. Now as long as A's are coming, we remain in state Q. as long as A's are coming, last one symbol is A. As long as A's are coming, the last one symbol is A, we should remain in final state. Now what if B comes? If B comes, last one symbol is not A, we come back to state P. We come back to state P. Here we come back to state P. Again, as long as B's are coming, it will remain in P, and whenever you find A, we go to final state Q. So if B comes, we remain in P, and if A comes, we go to final state Q. If A comes, we stay in final state Q. So if you see this processing, whenever last symbol is A, whenever last one symbol is A, it is going to final state Q, and whenever last one symbol is not A, whenever last one symbol is not A, it goes to non-final state P. So this is the basic logic. Here length of A, condition is W ends with A, length of A is 1, number of states is 2, so number of states is n plus 1, where n equal to length of A, which is 1. Now let's come to this problem. W ends with AB. So here, while processing the string, if the last two symbols are AB, DFA must be in final state. If the last two symbols are not AB, the DFA should be in non-final state. So first we draw the basic part of the DFA. On A, go to Q. On B, go to final state R. So whenever we find last two symbols as AB, we should reach to final state R. Now here also the processing starts in state P. As long as B's are coming, we remain in state P. As long as B's are coming, string cannot end with AB. Now if we find A, so here we are in P, here we are in P, and for this B also we remain in P. Now when A comes, we go to state Q. Now as long as A's are coming, we remain in state Q itself. But why? As long as A's are coming, we remain in state Q, and if B comes, we go to state R, because using this A and this B, the string may end with AB and you must be in final state. So if A comes, we remain in Q. Now if B comes, we go to R. So here last two symbols are AB. Here last two symbols are AB, and the string processing must be in a final state. For that reason, on first A we go to Q, on next edge we remain in Q itself. Now over here we have processed this much part of the string, but we may not know whether string processing has ended or not ended. In case of substring, once you find AB, you are sure that the given string has substring AB. So in final state we added self loop for all the symbols. But in case of ends with condition, we cannot simply add self loop for all the symbols in final state. We have to calculate the transitions. So we will continue developing the logic. Now if A comes, now what to do if A comes? While in B, what to do if A comes? Now if A comes, we come back to state Q, because using this A and this B, we can go to state R. Using this A, so here we came to state Q. Now if B comes, we can go back to state R, and here if string ends, we accept the string, otherwise we have to continue processing. Now while in R, what if B comes? while in R, if B comes, we have to come back to state P. Now what is the reason? If B comes, we come back to state P. Now if A and B come, we go back to state R. We cannot come to state Q. From R, we cannot come to state Q. Because if we come to state Q using B, then using BB, it will go to R, which should not happen. Using BB, if goes to R, the string will end with BB and it will be accepted. It should not happen. We have to come back to state P, so that now if AB comes, it will go to R. So this is in state P. If B comes, it will go, while in P, if A comes, it goes to Q, and if B comes, it will go to R. Again here, if string ends over here, it will be accepted. Otherwise, we have to continue processing the string. So every time last two symbols are AB, it is going to state R. Every time last two symbols are AB, it is going to final state R. So here length n equal to length of AB equal to 2 and number of states is n plus 1 equal to 3. So this is regarding number of states. Now we have to design W ends with ABAA. Now for length of ABAA is 4 and it is not as easy as these two cases. We have to develop logic and we have to develop a procedure. So let's look at that case. Now let's consider case W ends with ABAA. So this is the basic required structure of the DFA. As long as B's are coming, string cannot end with ABAA. So if we find ABAA, then we have to consider possibility if string ends now, it should reach to final state, we accept the string. But if string does not end, we have to continue processing the string. In case of substring, once you find ABAA, remaining part of the string is processed in final state and you accept the string. For that reason, in case of substring, there is self loop for all the symbols in the final state. We cannot do the same in case of ends with case. Here at final state also we have to calculate the transitions. So here we are going to calculate transitions such that for state Q, last one symbol is A. Significance of state R is last two symbols are AB. We are going to calculate transitions such that significance of state S is last three symbols are ABA. For state T, last four symbols are ABAA. For P, last symbol can be B, last two can be BB or B power 3 or B power 4. Here length of ABAA is 4, so here we stop at B power 4. Now if A comes, it goes to Q. Now significance of state Q is last one symbol is A. If B comes, it goes to R. But what if A comes? Now in state Q, last one symbol is A, another A comes. So we have to check, is there any state which remembers last two symbols are AA? There is no such state. So from left, remove one symbol and check, is there any state which remembers A? So it is state Q itself. So what does this mean? From P, if A comes, using this transition we go to Q. So from P on A we go to Q. On next A we remain in Q itself. This A is handled in this loop. After that, if BAA comes, we go to final state. After this A, if BAA comes, we go to final state. That's why we have added this loop. At R, if A comes, we go to S. But what if B comes? So significance of R is last two symbols are AB. After AB, another B comes. Check, is there any state which remembers ABB? There is no such state. So from left, remove one symbol and check, is there any state which remembers BB? So that is state P, initial state. So from R on B, we come to initial state P. The reason is, if we have ABB, then from any part of ABB, we cannot use any suffix and continue to get ABAA. Now in this case, at Q, Q remembers A and another A comes. So in this part which is so far processed, we can use this suffix A. If BAA comes, we can go to final state. Here we cannot do that. From any part of ABB, we cannot use any suffix and use that to get ABAA. We require all four symbols of ABAA, ABAA. That's why we come back to P. If ABAA comes, we go to final state. Now coming to state S. If A comes, we go to T. What if B comes? ABA. Significance of state S is last three symbols are ABA and B comes. Is there any state that remembers last four symbols ABAB? There is no such state. So from left, remove one symbol. Is there any state that remembers BAB? There is no such state. Again, from left, remove one symbol. Now check for AB. So it is state R. So from S on B, we go to state R. So what does this mean? Once you using this A, this B, this A, we can go to state R. So from AB, this is the part of the string which we have processed so far. We can use this suffix. After that, if AA comes, the string may end with ABAA, so we should reach to final state. So using A, we come to state S. Using this B, we go back to R. So A, B, AA, we should reach to final state. Now let's come to state T. For T, last four symbols are AB, AA. Now what if A comes? Is there any state which remembers ABAA? There is no such state. So we remove one symbol from the left. BAAA, there is no such state. Again remove one symbol from left. AAA, there is no such state. Again remove one A. For AA, there is no such state. Again remove one A. Now we find state Q. So from T on A, we come to state Q. So what does this mean? So earlier we find ABAA. The DFA processing is in state T. So while processing the string, we found ABAA, but the string is not complete. We found another A. So we come to state Q. Now this, using this A and BAA, it should reach to final state T. Using this A, so far the processing is over here. Now using this suffix A, if BAA comes, it should reach to final state. So we have handled transition of A. Now we have to handle transition of B. So we have AB, AA and B comes. Now no state remembers 5 symbols. From left remove 1. BAAB, there is no such state. AAB, no such state. AB, yes. AB is remembered by state R. So from T on B, we come back to state R. So what does this mean? We have ABAA. So here we reach to state T and now B comes. So using this A, this B, this A and this A, B, A, it will come back to state T. So using this B, we come to state R. Now if AA comes, it will go to state S and then state T. So after ABAA, we get B, then A, then A. So here again we get ABAA. So this is first ABAA for which it went to final state T. After that we are handling transition for B, for which we come back to state R. And now if AA comes, it will enter state T. So this is the required DFA. So this is the logic and procedure which is required for ends with. Length of ABAA, n equal to 4. Number of states is n plus 1 equal to 5. So you may think that this is lengthy procedure, but if you practice, this will not take more than 1 minute. In less than 1 minute, you will be able to draw DFA. Here value of n is 4. In GATE exam, this string ABAA or n equal to 4, it will not be more than 3 or 4. It will be at most 3 or 4. Now if you practice even for length 4, you will be able to draw the DFA in less than 1 minute. Now for practice, you are given a document, link is given in the description. There we have handled cases, string ending with BABA, BBBB, ABAB. So you draw DFA where string ends with BABA, W ends with BBBB and so on, and you verify your answers with the answers given in the document. If you practice, this is very easy and you will be able to do it very fast.